So this is the distance between the two plates. And distance would be measured in meters. And what about area? Let's hop back up here. What would area be measured in? Meters squared. Okay, great. Now there's one other component to this capacitor. If I hop back over here, and that's what's between the two plates. I mean, I know there's an electric field that exists, but what's the stuff between my two plates? Is there anything stuck in between my two plates? I can remove the electric field lines there. What's in between my two plates? Air. Very good. So, how the electric field can permeate that space depends on what material is between your two plates. So if we push a silicone or a ceramic material between the two plates, the electric field set up by the two plates will then affect the protons and electrons in that material, creating an electric field in the opposite direction. And so if you have an electric field down and an electric field up due to the dielectric, then you're going to get a weaker electric field between the two. So you'll get a different capacitance because the affinity for those charges to be there together changes. But we don't have to cover dielectrics in this course, but you do need to consider the fact that there is air between, or no air, pardon me, vacuum between our two plates. And so the constant that we need to use is the permeativity, I said the wrong word, the permeativity of free space. And the symbol is an epsilon, not. Okay, so this is our permeativity, and I'm going to permittivity of free space. And it has a value, and I'm going to write it right above it because I kind of ran out of space. It's 8.85 times 10 to the negative 12, and its units are Coulomb squared per Newton meter squared. So I'm giving you the units there so that we can work our way back to figure out what is the unit for capacitance. So this is our capacitance. And let's look at our units. I'm going to scooch just a hair here. So our capacitance, C, whatever that is, will be equal to Coulomb squared per Newton meter squared. Did I put a square up there? Yeah. I forgot it earlier today, so I had to double check. Times the unit for area, which is m squared, divided by meters. So what's that going to leave us unit-wise? Coulomb squared, definitely, divided by Newton meter. Does anybody remember what a Newton times a meter was? That's a joule. It's energy. That's right. So Coulomb squared per joule if you want to. And that's still a mouthful. So we name this a farad after Michael Faraday. And a capital F is the unit that's used. And 1 farad is a huge capacitor. So most of the capacitances that you will see in problems will be microfarads. Remember the micro symbol? So like 10 microfarads, 3.3 microfarads. You might even see 2 picofarads. Pico is times 10 to the negative 12. So you're probably going to see a prefix that's a times 10 to the negative something in there. Okay?